Okay, in this video, I'm going to be focusing on a little more on domain and range. Okay, so far, all you know about domain is that domain involves the x's, okay, and range involves the y's. All right, so I wanted to look at domain and range from graphs. I also want to just look at whether or not these are functions, just to get a little more practice with that. So if we have the graphs in front of us, we can tell whether something's a function based on whether it passes the vertical line test or not. The vertical line test says something's a function if you're unable to find a vertical line that would cross the graph in more than one spot. So see on like y equals square root of x, every vertical line I draw is only going to hit the graph in one spot. Okay, so I'm going to just indicate whether it's a function or not up at the top. I'm going to use F for function and F for not function. Okay, so let's do that on all of these. So y equal 3, no, a vertical line would only hit the graph in one spot. Y equal x, that's a function. Y equals x squared, a vertical line would only cross the graph in one spot, so that's a function. Same thing with y equals x to the third. Okay, even the cube root of x appears to be a function. You know, a vertical line would hit the graph in just one spot. When I get to x equal y squared, though, do you see how a vertical line would hit it in more than one spot? That's a classic example of something that's not a function. Circles, not a function. Okay, absolute value can be a function, just like something squared can be. See, y equals x squared is a function, but x equal y squared is not. Notice a squared on the y. Okay, that's a big indicator that's not going to be a function. So with y equals absolute value of x, a vertical line would hit the graph in just one spot, but x equals absolute value of y, a vertical line would hit it in more than one spot. So y equals absolute value of x is a function, but x equals absolute value of y is not a function. Okay? And then all the rest of these are functions. See this one right here, no matter where I draw my vertical line, it's going to hit it only once. So function, function, these are functions, and y equals log x is a function. Okay, so I wanted to do that part of it. And then let's go on and look at domain and range of several of these. Probably won't do them all, but I'll just do selected ones. Okay. All right, so a whole bunch of these are going to have a domain that's not very interesting. You know, the domain, remember, is all real numbers that you can plug in for x that wind up giving you real numbers out. And then when you have the graph, you're actually being shown what the ordered pairs are, so you can actually visibly see what the x's and the y's are. So when you're thinking about domain, it's like what I do is I think about, if I'm looking at a graph, the domain is going to be looking at the leftmost and the rightmost values. And for range deals with y's, so it's like you're looking at bottom and top, bottommost and topmost values, okay? Lowest and highest. All right, so let's go through and let's do domain on these. Okay, so I'm going to do the domain. I'll do that in blue. Okay, so the domain. So a whole bunch of them are going to have a domain that's all reals, and this is how you say that using interval notation. All right, so that one, this one, domain would be all reals. This one, the domain would be all reals. So we're looking at how this keeps going on up and out as it goes. So you would have an ordered pair with an x way out here. Okay, it would just have to be really high up. Okay, the domain would be all reals on that. This one would be all reals. Okay, that one would not. Okay, this one would be. The one below it would be. Okay, so we're looking at if we took these points and we imagined, you know, what the x's are for each of these points. It's almost like you'd be projecting the ordered pair down to the x-axis or up to the x-axis and just see what would be covered up. the domain would be all the x's. Okay, that would be true on all the ones I indicated with negative to positive infinity. So like even here, this would be here, and then it keeps going up. So I'd have an ordered pair with an x out there. The whole entire number line would be covered up if I smashed this function, smashed it so every point was projected onto the x-axis. Okay. All right, so there's a few more that are all reals. This guy down here has a domain from negative to positive infinity, and so does this guy. Okay, every point, if I projected it to the x-axis, I would have ordered pairs of all of those points. Okay. Now the rest of them have a more interesting domain, so let's take our time with those. Okay. All right, so if we look at this first one, this radical function, do you see how the function appears to kind of stop right there? We don't have any ordered pairs over here to the left, because remember when we tried plugging in negatives, we got a negative under the radical, and so we didn't have a real number, okay? So the graph just shows you where the real numbers are located. And you see how this point right here has an x-coordinate of 0, and then these points have x-coordinates that go up from there. The domain on this would be all the points from 0 to infinity, including 0. And the bracket on the 0 just means 0 itself is included. Okay? Now, if you look at x equals y squared, that was a relation that was not a function, but we can still talk about domain. The domain is the x's, but it's not just the x's that were in our list. It's all the x's that you possibly have. So you have to imagine that continuing. But do you see how there was nothing over here to the left? Okay. So the domain was from 0 to positive infinity again. All right. Now this one's really tiny, so it was kind of hard to see. But these points here, this was at 1, 0. And this point over here was at negative 1, 0. Let me blow that up a little bit. Okay, so the domain would be from negative 1 to 1. If you smashed all these points to the x-axis and all the ones down there, it would only cover up in between negative 1 and 1. So that's the domain from negative 1 to 1. Okay. All right, so here we have a domain. Think about what you think it is. Think about if you smashed every point to the x-axis, what would be covered up? The domain would be those points that would be covered up, those places that would be covered up, which would be 0 to infinity. All right, and then the log function, we found out that 0 gave us an error, and so did all the negatives. And so here, you didn't have an ordered pair right there on the y-axis, but when you were just to the right of it, it was okay. So just use a parenthesis on the 0 and keep going to the right. All right, now the two rational functions had these gaps right here at the y-axis. The 0 gave you an error when you plugged it in. It wasn't possible to divide by 0. And so you have this portion of the graph uses x's from negative infinity until you get right up to 0. And then the other portion keeps going after that, but there's a gap right there at the middle. So the domain here would be from negative infinity to 0. And then you jump over 0, go to the other side, and keep going. Okay? And that's the domain for this one also. Same exact domain. Okay? All right, so I wanted to just focus on domain and really concentrate on doing that on all of them. But let me go ahead and look a little bit at range as well, okay? So I'll clean them up a little bit and then we'll do the range as well. So for range, we're looking for y's. Let me go back to red to do the range. I'll do it in green actually. All right, so for range, we're going to do that in green. It's the y coordinates of the points that you see, okay? All right, so the range for this guy, it looks like all the y coordinates are 3. It wouldn't even be an interval. It would just be the set consisting of just 3. That's the only value you get. But here you see how this point has a y coordinate right there. This point would have a y coordinate right there. If you thought about smashing your graph to project the points to the y axis, do you see how the whole entire y axis would be covered up? That's why the range is also negative to positive infinity. It's all reals on that one. All right, now look at this one. Let me erase the blue that's on there. Now let me not try to do that. All right, so on this one, the range, do you see how there's nothing below the x-axis? If you smash the points to the y-axis, all you would cover up would be from there on up. So your range would be from 0 to positive infinity, and 0 is possible. Okay. All right, I can't see this, guys. I've got so much on there, so let me kind of erase all that. We're focusing on the range this time. This one, because of how steep it is, you pretty much see that, I bet. The range on this would be negative to positive infinity. I'll just point to that. The range is also all real numbers. You know, the lowest to the highest would be from negative to positive infinity. Okay. All right, now the range on the radical function in this case is also 0 to infinity, but it's really should be thought about very differently. You shouldn't see it the same. With the domain, we were projecting the points down to the x-axis. Okay, for range, you should be thinking about what would be covered up on the y-axis. So the reason that turned out to also be from 0 to positive infinity is if we smashed every point to the y-axis, we'd also have everything covered up from 0 on up. See, this keeps going out and up, so you'd have points as high up as you need them to be. All right, let me clean off the domain so you can think range. All right, this one's the same way. This one's going to have a range the same as the domain was. The range is also going to be negative to positive infinity in this case. But for a different reason. This point would be here, this point would be here, this point would have a y coordinate there, this point would have a y coordinate there. So if I smashed everything to the y-axis, it would cover up everything from negative to positive infinity. Okay. All right, now this problem is kind of interesting. The domain was just from left to right. You only have points from 0 to infinity, but the range, see, this keeps going up, up, up. This keeps going down, down, down. You have points down here, okay, and you have points up here, and you have points all in between. The range on this is going to be from negative to positive infinity. Okay, so the range is going to be from negative to positive infinity. Oops, I messed up on that. You never use brackets on your infinity symbols. Okay, so let me do that right. Negative to positive infinity. All right. On the circle, the range is going to be the same as the domain was because the circle was just centered right there at the origin. Sometimes circles are offset a little bit, so don't count on the range always being the same. But for this one, the range and the domain were both from negative to positive 1, okay? But it's because the lowest to the highest you have would only be between between negative 1 and 1, okay? All right, let's look at this guy. Study these later and make sure you kind of see the idea. So I'm looking at these points, okay? I'm thinking about what the y-coordinates are. And can you see how the y-coordinates, the lowest they go is 0, but then they keep going up as high as you want, okay? So the range would be from 0 to infinity, okay? The range on this one would be like the one above it, okay? So here the range would also be negative to positive infinity because of how that keeps going up, that keeps going down. So you have a lowest to highest and everything in between. Okay. So the domain on y = 1 over x was everything but 0. Well, it turns out the range is also everything but 0. Okay, the range is from negative infinity to 0, and then from 0 on up. Okay. All right, now it's for a different reason. We're not looking at the blue anymore. It's because, okay, these points cover up the y-axis as you go down. These points cover the y-axis up here. But you see how the graph kind of splits right here at the x-axis? It's jumping over that spot. We had an error. Oops. We had an error, or we never did get a 0 for a y coordinate. You'll never get that to happen. So the range turns out to be everything but 0. It's really not because of that point, though. That's actually what caused the domain. All right, now the range on this one is not the same as the other one because you see we have no points below the x-axis. So the range is actually only going to be from 0 on up, and it does not include the 0. See, those two branches kind of get close to the x-axis but never hit it. Okay. So we're thinking about up and down now. The lowest we get is close to 0. The highest we get is as high as we want to be. All right, that's also the range for this one. It's from 0 on up, not including the 0. That gets close to the x-axis but never hits it and keeps going on up. This one has a range from 0 to infinity as well. Okay, and then the range of this one, actually, see how that arrow keeps going down? You have y coordinates as low as you want to go. And then this, even though it's rising very slowly, this does keep rising. So you eventually can get a y as high as you need it to be. It just takes a while. So that would be from negative to positive infinity. Okay. All right. So I wanted to look at the domain and range of some basic graphs. Okay. The video is getting long, so I'm going to stop it and then do another video using some other examples of a little more complicated looking equation. And we'll focus again on doing the domain and the range from the graph.